Hi, everybody. Welcome to Percona Community Live. This is our community portion of Percona Live. We're excited to have you here, and we hope that you're enjoying the content that's out here streaming for free. For those who couldn't attend Percona Live in person, this is specifically for you with speakers who couldn't attend either. But we do have all of the sessions from Percona Live recorded, and they are available on our website. So if you go there, you can register for the app, and you can browse and watch sessions on demand from the Austin in-person event. But today we're here to talk about Postgres and the mistakes that we see happening over and over again. Now, typically I have a partner in crime in this, someone who helped me build these slides. That would be Barrett Chambers. He could not attend today and make it, so I'm going to be flying solo. So hopefully I can bring all of the fun and excitement that Barrett would generally bring in this session. Now, I'm the head of open source strategy, or the HOS for short. Here at Percona, I've been in the ecosystem for a long time. If you follow anything that Percona does, you probably run across me once or twice at least. I also have a podcast, so if you are interested in getting some awesome sessions on various topics in the open source space, the database space, feel free to subscribe and like the HOS Talks FOSS podcast on your favorite podcast app or on YouTube. Now, when we talk about mistakes that people are making or the sins that people make when it comes to Postgres, the first place that I often want to look is I want to look at what we're seeing from our support community. Now, Percona provides 24/7 support for Postgres, and that means that people are calling and asking us for help when they run into situations they can't handle on their own. And we do have some metadata about what sort of issues people are opening. So let's take a look at that. So the most asked support questions tend to fall into three main categories, right? Configuration, setup, and installation. So, or upgrades as well. So how do I do those things? I might not understand how to tweak something. Something's not working quite right in my setup, so I need some help there. Then we also have a big portion of tuning and monitoring. So how do I find issues? How do I fix slowdowns or things aren't behaving quite the same way that we would expect? Okay. And then we also have HA replication issues. So things are not failing over. Maybe replication has stalled. Maybe it's not, keeping up. How do I fix that? Maybe it's just how do I set that up? Now, of course, we do have some things around bug crashes, backups, and security, but you can see that the vast majority, almost, 3/4, actually a little more than 3/4, falls into that HA replication, tuning, monitoring, or configuration setup. And there are a lot of things that could drive questions in those space. So let's talk about some of the more common ones that cause issues. Okay. Now, when we talk about performance tuning and HA, and we talk about, the configuration and the setup, oftentimes Postgres is installed alongside other extensions or tools. And that means that there is a high likelihood that some of those extensions and tools could be causing issues. So I'm going to count down, and number 10 on our list of things that are causing, issues and cause problems are selecting tools that don't necessarily meet what your requirements are, or you don't understand how to use them. Okay, just like this guy who, hey, he probably knows how to use a saw, but he doesn't know how to use a bench or a table because he's using his friend's back as that. Not a good thing. So a lot of people will deploy some of the great tools in the ecosystem, but not quite understand the nuances or the difference. Let me give you a couple examples of this. So PG Bouncer, PG Pool, HA Proxy, these are popular tools, but they do things a little differently, right? So PG Bouncer is really there for connection pooling, whereas PG Pool provides some connection pooling, but also load balancing, but it's not as lightweight. So if you wanted to deploy HA Proxy and PG Bouncer, you can get the same impact as PG Pool, but you have to have two tools. Sometimes people will assume they'll get load balancing and just install PG Bouncer, and that's not necessarily correct. And you won't find that out until an issue happens, right? Server goes down, you're like, oh, wait a minute, I should have some sort of load balancing. I should have some sort of failover. And it's not necessarily working. Or maybe you're using connection pooling across multiple, nodes, and it just doesn't work. So understanding the tool selection here is really critically important. But probably a better example of this is actually on PG Repack. Okay, so probably one of the most widely used tools for cleaning up, that space, that dead space that's in the database. So there are some issues, however, if you use PG Repack, right? Locking issues can occur on busy systems. Some DDL operations can be frozen or killed. So there's actually quite a few nuances to running this tool. And if you kick this tool off and you have a high production workload, you could run into issues you didn't expect. And so often what we'll see is a lot of those performance issues that do occur come from someone who they have a tool, they're running some maintenance, they're doing something that should be lightweight, and what should happen, or happens 99% of the time, doesn't happen that 1% of the time and causes a cascading impact. So understanding not only the tools, but the nuances of the infrastructure and the technology that you're running is critically important. And there is a blog on this. I would encourage you to check that blog out. Now, number 9. So you might have the right tools for the job, but are you secure? Have you set up security? And so unfortunately, a lot of people treat database security like this gate. It's totally secure, right? Totally secure. So if everybody stays on that path, they're not getting through it. But they leave a lot of holes open. And so we do regular surveys of the community, and what we found was 1 out of 10 in the database community, so actually a little more than 1 out of 10, were impacted by some sort of database security issue. And that was up from the previous year. So this is a real issue that does occur. So you have to make sure that you are setting the database up properly to be resilient and secure. And some quick tips here are to avoid some of these situations, right? You have to use SSL to encrypt traffic. Otherwise, you're sending data that can be sniffed and it can be, redirected and then reused. Also, opening up Unix socket parameters can cause some issues. But probably the most common security issue is over granting permissions, right? So you have a user, it's an app user, you grant it full permissions on the database to do everything. Somebody gets onto the app server, all of a sudden they can, weed their way back into the database server and they have full access to do everything. That is an issue and something that you need to pay very close attention to. Also, you have to understand that there are some best practices that might be different than how you've operated in the past. Things like storing everything in the public schema. Or maybe you've never done any sort of auditing. Well, as you get bigger and you run into compliance type regulations, you will need to look at, ways to kind of come back to the security side and prove that your database security practices have been consistent and have prevented issues to the best of your ability. Now, the good news is, security issues are something that we're all hyper-focused on. So whether we are looking at, different ways to encrypt data or to keep, intruders at bay, as new releases come out, you do get some additional help. So for instance, in Postgres 14, Scram SHA 256 is now the default authentication, so it's harder to crack passwords. Previously, this was MD5 by default. Now, we also have predefined roles. So one of the problems with role-based security in most databases is it's a pain in the rear if you're trying to just give people read access to everything or write access to everything. And you'll have to go through and you'll have to get all the objects. And a lot of people just give up and they're just like, I'm just going to grant it all. I'm just do everything. And so in Postgres now, there is a PG read all data and a PG write all data. So something that's a little easier and it can be a bit more secure than trying to remember, did I grant that? And maybe I didn't. So let me just give full permission to everything. So you want to avoid that. So security is a huge, huge issue. Now, of course, I can't not talk about Postgres without bringing up our number 8 issue, which is cleaning up after yourself. Okay. Um, you know, and you probably all know that I'm going to be talking about vacuuming here. Okay. So those who don't know Postgres, as you update, you delete, you make changes to data, it actually leaves that data in place, and then it's marked for deletion later on, and then a vacuum process will run either in the background or on a schedule that you set up to come back and clean up that empty space. And things can get quite dirty, and if you aren't careful, this can be a significant source of performance problems. So the proper use of vacuum, whether this is automated or not, is incredibly important. Okay, and so there is a process that's called auto vacuum that will run in the background, and you need to understand how to tune this. Okay, and so you have got the auto vacuum threshold and the auto vacuum scale factor that will tell you how dirty the database or the tables can get before you take action. Okay, and then you can also tell the system how many auto vacuum workers to run in parallel. So you can say things like, "Oh, once we reach a certain percentage of space that's dirty or dead, let's go ahead and clean it up." But probably the biggest issue that you see in this space is with people who delay or push off the vacuum because it's such a intensive process in a lot of cases. And they risk having issues with a transaction ID wraparound because that old data also will have transaction IDs that's associated with it. And until you clean up that data, can't release it for the future usage. So you'll actually run out of transaction IDs and it will force the issue on you, and that causes some pretty significant slowdowns in some big systems because then you are forced into taking action. We do have a couple of blog posts on that, as well as a couple of podcasts if you're interested in learning more details on that specifically. But understanding how fast your data is changing, understanding the workload patterns, when maybe vacuums are more appropriate, and then looking at the tools. I mentioned PG Repack. That's something that is actually a really valuable tool that can help, ensure that you're getting good, performance out of your maintenance operations, and you're keeping ahead of this issue. Now, in PG-14, there are some enhancements that were introduced specifically for vacuum, right? So, the way that tuples are compacted has improved. There's been a pretty significant work on improving the overall performance of vacuum. So that's a really good thing. So faster vacuum, faster maintenance, less impact on the system. Always appreciated. Now, you've got vacuum. We've talked about tooling. We've talked a little bit about security. But one of the issues that comes more from the application side, and this is more of a design discussion, is how you are connecting to the database. Now, I mentioned that there are connection pooling tools, as well as load balancing tools that you can use. But one of the critical things in the Postgres space that many people overlook is that the number of connections matters immensely. So having too many connections, especially in Postgres, is really, really challenging. Okay, and the reason for that is Postgres, the connection model, has memory allocations for each connection. And so you could see 20 to 50 gig or megs of memory used per connection. And there isn't, that threading model that MySQL has, for instance. And this means that, as you are scaling those connections up. And as they're getting bigger, you're going to be consuming more and more memory, which is going to cause more and more of an issue, right? And then you're going to potentially start to run into swapping issues or other problems. So because of that model, you need to be very careful. We often recommend that you set up connection pooling. So PG Bouncer plus HA Proxy or PG Pool 2. But realize that each of those tools may in fact introduce latency to the system because it is an additional hop. So make sure that your connections are taken care of. If your app is opening up a lot of connections, make sure that you do have some connection pooling somewhere in the overall system and setup of this. Now, in Postgres 14, this has gotten a little better. These numbers might not look significantly different, but you can see that the number of concurrent connections has seen some improvement with the most recent release. Now, it'll be interesting to see what Postgres 15 does, if anything, to help improve this as well. But Postgres is generally pretty good about incremental improvements across the board on performance, security, and other topics. So we'll be looking out for that. Now, of course, I mentioned that nearly 30% of all of the issues people open up are around setup and configuration type issues. So it's no surprise that number 6 for us on the list of sins or issues that people continually come back with is people who think that the default configuration is the way to go, right? It was built by smarter people than me, so I'm just going to leave it as default. There are a lot of issues if you just leave the configuration left alone. Namely, you have to realize that the database out of the box is designed for a very general purpose use case, and it is not optimized for what your workload or your servers have available. And so there are some very, very rough estimates here, okay? Effective cache size, shared buffers, where you want to set them. Work memory, some people say that this should be, much higher than this. It's going to vary depending on the system that you're running. And also, don't forget those vacuum settings. So from a performance perspective, there are some things you want to look at. Obviously, any database, the more that you're storing into memory, the more effective or performant the database is going to be. So obviously, these shared memory settings are going to be critical. And then when you look at the vacuum processes, those are going to help, and we talked a lot about those as well. But the other thing that we haven't talked about is actually on the wall side. So when you're talking about like the transaction log, when you're talking about either for replication or for backups and doing hot backups, having those logs tuned can make a significant difference in random slowdowns and issues. So the wall settings by default are going to have checkpointing happen fairly frequently, which might not be a good thing if you have a heavy, bright system. So typically, and again, I would say that every application, you want to take these recommendations with a grain of salt. You want to have wall log file sizes that are slightly bigger, maybe a gig, sometimes even bigger than that. But again, depends on the application. I don't want to give you, advice that everyone should go out and set this. But you want to look at the checkpoint timeouts, the max wall size, and then the checkpoint completion targets. And then, of course, as the system's processing, you want to make sure you have enough data to understand what's going on. And so having logging, debugging set up like, log temp files, log checkpoints, log auto vacuum, right? So those are going to tell you when events are happening so you can go back and debug later on. So my question to you for number 5 is, do you over or do you under? And what do I mean by that? Well, you see, what I mean by that is over or under indexing. Okay? So one of the problems is more is always better, right? that philosophy. And I mentioned with connections, that's not necessarily true. In the case of indexes, obviously having too many indexes can cause issues, but having not enough indexes could also cause issues. So it's like the Goldilocks syndrome, right? This one's too much, this one's too, or too hot, this one's too cold, this one's just right. You want to make it so it's just right. Okay, every column doesn't need an index. Most columns that you're filtering on regularly probably should. But you can look at, there are some views out there, pgstat all indexes, pgstat IO all indexes, to see what indexes are being used, see which ones you might be able to get rid of, and understanding the difference between the different index types is critically important. Now, the reason you don't want to have too many indexes is not only will the indexes impact the performance of select statements in a positive way, it will degrade performance of updates, inserts, and deletes, and it will cause potential slowdowns if you have too many as well. So keep that in mind. It's very important. Now, of course, in Postgres 14, there are some enhancements as well that have occurred to reduce some of the bloat and some of the issues with indexes, improving them. So I think a lot of these go hand in hand with some of the auto vacuum features that were implemented as well, but also can help boost performance a bit. Now, Postgres is a outstanding ecosystem. I mentioned that there's a lot of different indexes. In fact, knowing the different types of indexes is critically important, right? So, btree, hash, gin, gist, brin, there's an index for almost every use case if you're looking at, for something. And knowing which one can be deployed when is important. And Postgres has developed a massive list of extensions that you can use, not only from an index perspective, but just extensions to the overall Postgres experience and core, which is great. We love extensible databases, but sometimes, again, more is not better. And a lot of people end up adding extensions just because they think in the future they might need that extension. And that is a classic blunder, right? And so while Postgres is super extensible and they are wonderful and there are many different awesome extensions out there, you have to understand that not all of them are designed to work together and have been tested to work together in all cases. So as you start to integrate them, they can introduce issues. I've had extensions that have caused certain database workloads to completely crash the server. I've had extensions that when you combine the two, like two extensions together, it causes performance issues. In fact, one of the first things that support engineers told me that they recommend if there is a performance issue is have you turned off the extensions you don't need, because a lot of times those extensions cause weird problems, especially if they're not from trusted or reliable sources. So this is an area where you need to be careful, because obviously you're adding an extension because there's some benefit to it, but the question is the benefit worth it? And are you really going to use it? Because every release that comes out, every new extension that comes out, there's a possible conflict, and you can't guarantee that the compatibility of the extensions has been thoroughly vetted to the point that Postgres and the core engine of Postgres has been tested. So be very careful with extensions, even though they can provide some awesome, awesome things. Now, of course, we've talked a little bit about performance. We've talked a little bit about, objects, schema. Talked a little bit about, the configuration. But one of the things that we haven't talked about that does take up a significant portion of our support engineers' time is outages, HA, right? So what sort of issues are causing an outage, and, what sort of things are out there? Now, if you have a system that has a required SLA, you have to have HA. HA is not a substitute for backups. Backups are not a substitute for HA or high availability, right? There is a significant difference between those two. Just because you have one doesn't mean the other is sufficient. Just to give listeners a heads up on the difference here, when we're talking HA, we're talking about the ability to fail from one server over to another and be able to recover quickly by redirecting the workload to a standby server. Whereas backups, we're talking about a physical copy of data that we can then restore over a broken system. Now, why are these two different? The classic example is you can have a database that is being backed up, and if you drop a table in that database in your HA setup that has a standby server, the table drop will propagate to your standby. And so you will eventually pull up that, fail over to the other box, and it will still be missing the data. This is something that we've seen happen numerous times. It's not a good situation. That's why you need both backups and HA. And this is a common problem. Okay, whether you're running in the cloud or not. Many of you might be relying on, whether it's Aurora RDS or RDS Postgres or Azure SQL, and it's got built-in backups, it's got some built-in HA. But understand that, cloud outages happen and regular outages happen. And you can't outrun these outages. You have to understand what your strategy is and how to employ it. Right? This is a common problem where, you trust a service provider. You have the button that allows you to do the failover. You've set up something in a different availability zone, and then the cloud provider has an outage, and it just doesn't work because the availability zone where everything was stored is out. So what do? And that means that you have to make sure that you've configured it in such a way where you're going to fail cross availability zone or maybe even fail cross cloud provider. So understand outages do happen, and 1 out of 5 who are running in the cloud experience this. 1 out of 3 who, regardless of if they're in the cloud or somewhere else, experience this as well. So odds are you're going to run into it. And, really, the story is Postgres is great as long as it's up and running. And if it's not up and running, then obviously, that's an issue. So make sure that you are prepared to recover from a variety of outages and have tested the scenarios and have those scenarios documented and scripted and ready to go. When was the last time you tested a failover or a backup? I shudder to think of the times that I have had to talk to a customer where they have said, well, I have a backup, but my backup can't be restored. I never tested it. If you are taking backups and they are unrestorable, it's a waste of time and effort. So you have to, if you're doing this as a preventative measure, you have to at least once in a while ensure that backup is a restorable copy. Again, super critical. Now, as we talk about HA and backups, some of the things that you want to remember, right? First of all, those wall settings that I mentioned from the transaction log are going to be incredibly important for both replication and backup and recovery. So make sure that they are set appropriately. Make sure that those configurations are appropriate. But how are you managing your HA? Is it a click button? Do you have to go in and manually do something? That's going to be an issue if you have a high mean time to recovery, right? So if you need to get up and running very quickly and you are not using automation to do your failover, that's an issue. There are many tools out there that can do high availability and automation around failover when a node fails or has an issue. We use Percona quite extensively with something like HA Proxy, but there are dozens, if not hundreds, of tools that can do high availability automation. And so I would recommend that you look into these if you are not using them so you have some protection, because every second can count. If you're down, users are going to suffer, and that could potentially cause issues that have a cascading impact on the overall health of not only the application but the business itself. And also, when you talk about backups, what sort of policies and tools do you have, right? What are you using to do backups? Are you just doing like a base backup? If so, that could be a lot of overhead and it could be very difficult to restore. We've done some live streams where we've had to do that, where we've gone through and we've used the most basic of backups to try and do restores. And you've got to do some script foo, if you will, in order to get the right LSN number and where do you want to start and stop. So we recommend tools like PG Backrest. We also recommend things like having a minimum retention of 7 days of backups, just in case you didn't catch an object or an issue with a backup, so you have some protection. But also keep in mind there's different types of backups. You don't have to do a full backup every day. You can do incrementals or differentials, depending on your setup and the size of the database. So you might want to mix and match what makes the most sense for you, but realistically, you want at least one full every week if possible. And you want to make sure you're not just storing backups locally. That is also a problem. I've run into that. It's not fun when someone calls up and, my system's down. I need to restore from backup. Where's the backup? It's on the local drive. Well, is the server up? Nope, it crashed. Not much I can do, right? So you want to avoid that one. So HA backups, incredibly important. Make sure that you're following that. It seems like easy advice, but if 20 to 30% of people are asking questions or running into problems where they are experiencing an outage or having to, deal with issues here, there's not enough people who are paying attention to this area. So it is a big, significant problem. Now, number two, we talk a lot about performance, but performance, especially in databases, is really dependent on the workload that is running on the system. Now, we talked about some basic configurations, avoid just the default configuration. But when we talk about workload and tuning the database to the workload, this is where you're going to have a lot more adjustments than those best practices, right? Sometimes you have workload that evolves and changes over the year. For instance, tax season. Accountants are really busy for a couple months, but then all the rest of the time they're not really busy. So that workload change is important to understand and plan for. And I mean, that's not just a seasonal thing. It could be a weekly thing. It could be that you're busier on weekdays during business hours than off hours. But it also could be that you're write heavy versus read heavy. It could mean that you are, constantly processing data at night, all kinds of different things. But there is the ability to make some adjustments in tune, because this is where a lot of slowdowns actually occur, is not understanding the workload and how to get the most out of that workload. And right now, sad fact is, more than 50% of users who we talk to still say that they have slowdowns and performance issues, in their database layer. So over the last year, half of the people who are listening to this talk are going to say, yeah, there was some sort of performance issue. Not all of it's going to be related to workload, but this is a real problem. So this gets down to understanding and setting a baseline for what your system can do and can't do, right? So what sort of observability tools are you using? Do you have monitoring tools in place? Have you looked at what the limits of your system are? We use Percona Monitor Management for insight, but there are other tools out there. It doesn't have to be that. But what you want to do is you want to understand that if most of the time your queries, your latency on your queries is 100 milliseconds, and you're generally doing 2,000 queries a second, if all of a sudden you see an adjustment to 4,000 queries a second and a 500 millisecond response time for latency, that's a change in the workload that you need to be made aware of. And not only do you need to be made aware of, you need to dig into and figure out what changed to see if that's the new baseline, or to see if, it was a transient, thing that's going to go away, because you might have to then adjust and add additional hardware or rethink how your deployment mechanisms are, or how you even design the system, right? Really, really important. And you do this in the database side, and there are other things to look at, like what sort of use cases and queries are hitting the system. But this is not just a database side of things. You also want to look at the system itself and look at that, that data for what's happening on the system, CPU, memory utilization. But you also want to tune the various kernel parameters in the OS to match what the expectation is for that workload and what the expectation is for the application. And understanding not only the baselines for the database, the application, and the systems, but also being able to see what changes you can make to improve those baselines and give you more opportunity to grow. Now, any guesses on what the number one thing that we see over and over again? Okay, I actually have two, but so there's going to be like a number 0, but it's like a bonus round. But the big thing that often happens, okay, is when people design something that is obviously a mistake, right? If you look at where we as SREs, DBREs, DBAs, people who are dealing with the database side spend our time, where do you think that is? Okay, I'll run down where that is based on our survey. Number one, building automation. That makes sense, right? More automation that you have, the less work you have to do, more efficient you are. Makes total sense. Moving data between environments. Okay, right? So data from A, data to B, okay, yeah, hey, moving stuff around, I get it. Troubleshooting problems, 11%. 11% of folks said that they, spent, time troubleshooting problems. And that kind of goes into query tuning, right? So obviously query tuning is a big area, and that really is a problem, but it's also a performance issue. So a lot of query tuning efforts. But what is the number one thing where people spend their time and consumes most of their energy? That's working with developers on their application and trying to make this right. So it's that poor database design, right? By far the most common issue is really, really inefficient design. And that's because we've lowered the barrier for a lot of people to develop applications to the point where they don't need to think about the database side of things, right? They don't think about the schema in a lot of cases. They don't think about the queries they're writing. So they'll throw things into any sort of like structures that make sense or that they think are okay without any sort of thought process. I hear this all the time that, the impact of choosing the wrong data type can have a significant, detriment to your application. Using an integer or a numeric versus a varchar, for instance, that can add overhead that's in some cases 2 times slower, sometimes even more. Why? Because it's more efficient to process and to store and to handle the integer and the numerics. It's a smaller footprint, takes less memory, takes less disk, easier to find in an index, easier to process in, CPU cycles. So that design aspect is often overlooked because it's kind of, it's boring, right? For a lot of folks. And we've turned from a development standpoint to over-reliance on ORMs. So we try to hide and mask as much of the database as we can. And so that becomes a significant issue. Now, not only is there a database design issue, but people are really smart. And, this is, I'm going to call this a bonus issue, but this is really kind of hand in hand with the design side. You also have, this setup with a poor database design, with a Rube Goldberg design, right? So a massively over-engineered, system that has poor database design and is using all of the other 10 deadly sins that we mentioned, right? You've got a whole bunch of extensions that you might not need set up. You've got a whole bunch of tools that are just implemented because they might do one little tiny thing that you really didn't need it to do. And you build out systems that not only have one database, you have a dozen databases. So from an application perspective, and this has really led to an explosion in the number of database instances that are out there, right? So look at this growth rate. And again, this gets back to the more is not always better. The number of databases in production over the last 3 years that are of in environments that have more than 100 or more than 1,000 databases has grown exponentially. Look at that. I mean, we go from in 2019 we had almost 20% of people said that they had over 100 databases in production. Then in 2020 it was about 28%, and then in 2021 it was 42%. So we actually had almost a doubling the last year of environments or companies with more than 100 databases in production. And with those reporting over 1,000, it was over doubling because now we're over 20% there. That's a substantial number of databases out there. And the thing is, no, it is not the person with the most complex system that wins, right? And by far, when we talk about the design issues, whether it is the overcomplicated architecture, it's the underdefined schema, it's the bad database design, it's the wild and woolly things. This is the number one issue that our engineers see more often than not, and it is the number one problem that you need to avoid in order to ensure that you have a system that can run and a Postgres database that is happy and running well. So that's it for our session today. We hope you enjoyed it. Feel free to ask questions in the chat. So this session is recorded, but we will have people hanging out in the chat to respond to questions. So feel free to put them there. And we hope to see you next time. Thank you very much.
So my favorite. So when I sit down on a PMM, and the customer, it's already telling me, hey Marcos, we have a problem on this node, started at this time. Those are the first two things I need to know, right? Like which node I should be looking at and what time the problems started. So the first dashboard I will take a look is my SQL instance summary. I will make sure I have my the proper node selected. And then I will start going one by one on very much every panel. So what I'm looking for, of course, are anomalies. And I don't know what's going on. Like they only tell me things are slow. That's how it usually goes. They tell me it's slow. And so I have very little clues. Sometimes they will tell me some more clues, but if not, what I do is go search for anomalies on every panel. So sometimes it's good, or most times it's good to enable individual metrics on each panel, because they're gonna show a different picture. Because look at this, connections, it's only in the 20s, 30s. So it's dwarfed by the max connections. So when I turn on everything, I don't see anything. Like the connections are changing. Like you can see 28, 26, 30, 29, whatever. But I cannot see it. On the other hand, when I enable only connections, I can see it. And sometimes you will find a very large spike. Perhaps it was all the time 1, 2, 1, 2, and suddenly you got 40. And 40 connections, they could push enough load to make a problem. But again, you will not see the 40 connections if you have a 2000 line reference here. So turning on and off every metric is many times necessary. The same here, right? Like aborted connects. In this case, I can see all zeros, so I can ignore it. But otherwise, if you see a few and the time when the problem happened, then enabling just aborted connects will allow you to see the spikes. Then peak threads connected and average threads running. These are pretty important. Like this is telling me like the way this changes and the way connections change are telling me about the arrival rate and the residency time. And these are telling me about actual concurrency. This is when someone is asking you how much concurrency your database is having, or is withstanding, or is serving. I'm not sure what word would you like to use, but concurrency in MySQL is threads running. So
how many are active at any one time? And typically, exactly, it's going to be difficult to get more than that's the active ones that are consuming CPU resources, right?
That is correct.
So it's very difficult to get above the number of cores.
Well, it's impossible, right? I mean, you can always have some additional processing with hyper-threading if you don't count your hyper-threaded CPUs as cores. So a 16 cores with 32 hyper-threaded processing threads, it can probably do 32. Perhaps it can only do 20 plus. It heavily depends on how fast your memory is and how much different data those threads are accessing, etc. But yeah, number of threads running greater than number of CPU cores, that is very likely to become problematic. I can see you're pushing more load. Which is
I am not.
Oh, you are.
It's the dungeon masters pushing more load.
Oh, he's gonna start throwing me trolls from all the angles. So, okay, I haven't take a look at the resources yet, which at this point I will need to take a look. So at the very bottom of this panel, I have a node summary, and it's gonna tell me a bit about the system, but it's not giving me CPU cores. Oh, I thought I'd have it here. So I'm gonna have to go to system node summary. So virtual CPUs too. So with the amount of, am I looking? No, I'm looking at the wrong one. Oh my God, 8, that's much better. So 8 CPUs, I like to read here, so I can also see the speeds at which they are running, and I can see the amount of cache on each one. Something is a bit off here. Here it says 2, here it says 8. I have to guess this is delayed. All right, I don't care.
You're looking
if
at the
it's
last
8,
12 hours. Go to the last, like, change it to like the last 5 minutes or 15 minutes. Did it change the?
yeah,
So there you
course
go.
4 virtual 8. There you go.
Yeah, so for whatever, it's weird because some of these summary screens, I don't know when it takes the snapshot. It's something we should probably ask, because if you look at like a 12-hour period and the system wasn't running or it was on a different class of box, does it show you the first iteration or the last iteration or the average iteration?
Yeah, that's a good question. Like,
yeah,
usually, you know, in a more stable system, you will see this and you will know it's okay. But yeah, this we just started a couple of minutes ago, so it was prone to change.
By the way, I'm actually getting errors in the application.
You're getting errors? What kind of errors, dear customer?
I can't.
Let me see.
I can't connect.
Oh, you're You're getting connections aborted, timeouts. Let's see. And thread cache, you're creating threads. This is usually bad. Creating threads can be slow depending on your pthreads library and whatnot.